Hey there, kiddos. Here's your topics 8 and 9 video for your semester exam review. This is graphing equations and inequalities. They're both going to be together in one video. So let's review a few things first. The x-intercept, 0 of a function or solution, they're all the same thing. All those words mean the same thing. X-intercept, 0, solution. It's the point where a graph crosses or intersects the x-axis. So if you're being asked for one of those things, you're looking for that point. The y-intercept is the point where a graph crosses or intersects the y-axis. So number 1 here, the volleyball team's traveling to a game that is 120 miles away. Their average speed is 40 miles per hour. The graphed line describes the distance left to travel at any time during the trip. Find the x and y intercepts and state what they represent. So the first thing says, what's the x-intercept? Well, if we go to our definition, x-intercept is where the graph crosses the x-axis, so that's right here at 3, and so the x-intercept is going to be 3, 0. And what does it represent? Well, to find out what it represents, you have to look at your label and understand what the graph is about. This graph is about a volleyball team traveling to a game. X-axis is labeled as time, and so what that tells me is that right here at the x-intercept is that this is how long it took them to get to their destination. So this is the time it took to reach the game. And if you'll notice, that is in hours, and so it took them 3 hours to get to their volleyball game. Now the next one is, what's the y-intercept? Well, that's where it intersects the y-axis, which is this point up here at the 120. And so it's 0, 120 because the y value comes second in a point. And what does it represent? Again, this is a graph about a volleyball team traveling, and the y-axis is labeled as distance in miles. So this 120, and it even tells me in the words that the game was 120 miles away. So this is the distance they have to travel. That's how far they are away when they start their trip. So number 2 here asks you to find the x-intercept and the y-intercept of this equation right here. And down here you'll notice in the little blank that it doesn't say x-intercept, it says solution. That's because, if you'll remember, x-intercept and solution mean the same thing. So they're synonyms of each other. So to find the x-intercept, if you look at how we wrote our point up here, we wrote it as 3, 0. X-intercepts always have a value for the x and 0 for the y. So to find the x-intercept, I'm going to make this y equal to 0, which will just cancel out that term. So I'll have 1/2 x. This would become 0, so it will cancel out, equals -4. So to get what the x-intercept is, I just have to solve this for x. Well, I'm going to multiply both sides by 2 so I can clear out that fraction, leaving me with 1x equals -8. So my x-intercept is where x equals -8, and to write it as my solution, it's the point -8, 0. The y-intercept is going to be the point where the x equals 0, so it's the opposite of the x-intercept. So now I want for x to be 0, and I want to find out what y equals. Well, if I make this x 0 right here, this is going to cancel out, so I just have -2y is equal to -4 left. Well, I'm going to solve this for y by dividing both sides by -2, and I get that y equals 2. Because when I divide a negative by a negative, I get a positive, and so to write that, it's a point at 0, 2. So number 3, we just got to find the slope of this line. Well, remember, if you have a graph and you want to find the slope, step number 1, find 2 pretty points. Well, here's a pretty point, and here's a pretty point. And then I'm going to connect those 2 pretty points with a right angle so that I make this lovely little right triangle. Then I'm going to count my rise over my run. Well, my rise is vertical, it goes up and down, and to get from here to the corner of my triangle, I had to go down 1, 2, 3, and since I went down, it's negative. And then when I know my run, I count from the corner over to the other point, so I went over 1, 2, 3, 4, 5 spaces. It doesn't have to be a complete square, just how many spaces are there. There's 5 spaces, and since I went to the right, it's positive. So my slope is the rise over the run So it's negative 3/5. Number 4 wants us to find the slope of a line that passes through these 2 points. Now you got a couple of choices. You can use the formula, which you should know is the y2 minus y1 over x2 minus x1. But I prefer to not have to deal with this formula. I prefer to just take my 2 points and I'm going to make a table of those 2 points. And so my first point is negative 4, 6, and my second point is 5, 3. Then I'm going to do what I know about finding slope, and I'm going to find my change in the y values. So from 6 to 3 is minus 3. And the change in my x values from negative 4 to positive 5. You have to think about a number line. And from negative 4 to positive 5 becomes a change of positive 9 because they're getting bigger. And so my slope is the change in the y values over the change in the x values. And so my y changed by negative 3. My x changed by 9, and if I simplify this, I divide both by 3, I get negative 1/3. That's the slope of that line. So let's talk a little about some transformations. So we're going to sketch a graph of these equations on this graph using a different color for each line, and then we're going to talk about what's happening. So the y equals x is graphed. This is your linear parent function. It's already there. We're going to graph y equals 2x. Well, the slope of this line is 2 or 2 over 1, and there is no y-intercept, so it means that my y-intercept is just 0. So my graph is going to start at 0, and then I'm going to go up 2 and over 1, up 2 and over 1. I can even go backwards. I can go down 2 and left 1. It's just the same thing. And then I'm going to connect my points with a line. And so there's that one, and then we're going to do this one. The y equals 5x. I'm going to give you a second to graph it using just like we did, and then look at what's going on. So there is that line. Hopefully yours looks like mine, so we'll see what's happening. So how is the slope changing? Well, the slope of this first one was 1 over 1. This one's 2 over 1, and this one's 5 over 1. So the slope is getting bigger. And when the slope gets bigger and I increase the number in my slope, then my lines are steeper. So increasing the slope increases my steepness of my line. So number 6 here, we're going to do the same thing. We're going to graph these lines and then compare them. So I have y equals x already graphed. And so my next one is y equals 0.5x. Well, 0.5x is the same thing as 1/2 x. So my slope is 1/2. We want to use the fraction so we have a rise over a run. And my y-intercept is still 0. So we're going to graph that. We're going to go up 1 and over 2. We need to go backwards, down 1, left 2. And then we're going to connect them and make a line. So now let's do the other one, the 1/5 x. I'm going to do the same thing. I'm going to give you a second to graph it and check your answer. And so now we can compare what was happening with the slopes. Here is the third line. It's this one that's this less steep one, the shallowest line that's on there. How was my slope changing? It went from a 1 over 1 to a 1 over 2 to a 1 over 5. Well, that means that my slope is all getting smaller. I am decreasing the slope, and when I decrease the slope, hopefully you noticed that my lines are now less steep. So now look at number 7. My slopes are now not changing. I have a slope of 1, a slope of 1, a slope of 1, a slope of 1. But what does change is the y-intercept. Your linear parent function, y equals x, is already graphed. So we're going to start with the first one, y equals x plus 1. Well, the slope of that, because the number in front of the x is a 1, is 1 over 1. And the y-intercept is also 1 because I did plus 1. So that means it starts here at 1, and then I get to go up 1 and over 1. And since they have the same slopes, if you remember what we learned just this week, that makes them parallel lines. So the lines are not going to cross each other. They are parallel because they have the same slope and different y-intercepts. You see they do not cross. But I did move it up. When I changed that y-intercept, it scooted my line up from a y-intercept of 0 to a y-intercept of 1. So let's do the next one. X minus 3, so my slope is 1 over 1 again. Forgot my equal sign. And my y-intercept this time is negative 3 because that minus sign is going to act like a negative. Again, they have the same slope, so that means they're going to be parallel. But this one starts down here at negative 3, and then I get to go up 1 and over 1. And I can connect my line. And you'll see, as soon as I put my line where it's supposed to be, that those are now parallel. They don't cross one another, but now I've taken my original graph, the one that was already drawn, and now I've scooted it down. And this time I moved it down 3 units because I changed my y-intercept. Well, the next one, the slope is 1 over 1, but the y-intercept is 3.5, and I'm going to write this as 3.5 just because that's easier for me to graph. If you want to write 3.5, I don't care. They're the same thing. That means I'm going to start up here at 1, 2, 3.5. It's in the middle. So now when you count your slope, because this is in the middle of 2 lines on the graph, when you count your slope, to go up 1, you can't just go up to the grid line. To go up a whole unit, you have to go up to the next half. So here's your 1 over 1. It still has to be in the middle. Otherwise, you didn't go up 1. You can also go down 1 and over 1, but you have to end up in the middle because the down 1 means down a whole unit. It does not mean, or up a whole unit, it does not mean that you just went to the next grid line. And so if I connect those, put a line through those points, you should see, again, parallel, because they all have the same slope, but this line compared to the one that was already there, scooted up, got moved up 3 spaces because I changed the y-intercept. And so this question that says, how is the slope changing? Well, the slope changing it's not. They're all the same, so my slope didn't change. What did change was the y-intercept. And when I changed the y-intercept, if I made it bigger, my line scooted up. If I made it smaller, my line scooted down. So some summary, slope affects the steepness of the line. The bigger the number, the steeper the graph is going to be. The y-intercept affects the starting point of the line. So it affects where it's going to begin on the graph. And when you change the y-intercept, it takes a line and it moves it up and down. So now let's graph some equations and inequalities. Before you can graph anything, before you can put anything on a graph, y has to be by itself. So if I want to take this negative 1/2 x plus y equals 4, and I want y to be by itself, I've got to get rid of this negative 1/2 x term. Well, to do that, I have to add 1/2 x so that they cancel, but I have to do that over here with the 4 as well, and I can't really add those because this has an x but the 4 doesn't. So this becomes y equals 1/2 x, because I like to put my x term first, plus 4 because the 4 was positive. Now you have a slope and a y-intercept. We can graph it. So the y-intercept is 4. That's the starting point. The slope is 1/2, rise over run, so I get to go up 1 over 2. Or down 1, left 2 to go backwards. And then I will connect my points with a line. And there's my line for my graph. So step 1, solve for y. So let's take this one, 2x minus y equals 3. So I'm going to write it up here, 2x minus y equals 3. I want to get y by itself, so I'm going to move this x term by subtracting 2x. So I have negative y, and I'm going to put the x term first, so I have negative 2x plus 3. But this negative y is like having a negative 1 in front, and so y is not alone. I have to divide by negative 1. Every single piece. So you end up with y equals, a negative divided by a negative makes a positive 2x. A positive divided by a negative makes a minus 3. So here's my equation. Y-intercept is -3, so it starts down here. And my slope is 2 over 1. So I get to go up 2 over 1. Or down to left 1. Connect my points, make a graph. There's your line. So let's talk inequalities. The next two are inequalities. You're going to graph them the same way. Step 1, you want y by itself. So I'm going to do it down here underneath. I have -2y minus x is less than or equal to -8. Well, you've got to move the x term first. So add x. And like I said, I like to get the x to stay in the front. So this becomes x minus 8. And then I have to divide by -2. So I'm going to divide by -2 here to cancel. And then I'm going to divide every piece of this by -2. And remember, because I divided by a negative, this symbol has to turn around. So it becomes greater than or equal to. If you forget that part, your graph's going to be wrong. Now remember, there's a 1 in front of this x. 1 divided by -2 doesn't make a nice, easy whole number. So we're going to leave it as -1/2 x. And then -8 divided by -2 becomes a plus 4. So my y-intercept is 4. It's going to start way up here. And my slope is -1 over 2. So I have to go down 1 and over 2. Down 1 and to the right 2. Or up 1 and left 2 to go backwards. Now look at your symbol. Your symbol is greater than or equal to. It's got the underlined part in it. So that means that when I draw my line, it's going to be a solid line. I'll put it through the points just a second. So there's your line. And now we have to talk about the shading, because if you'll remember with an inequality, you can't just draw the line. We have to shade where the solutions are, because the solutions are going to be everything greater than that line. So I have to go to my line and I have to shade everything above that. So if I'm on my line right here, up would be this direction. So I have to shade everything up here, and so that's what my equation looks like, or my inequality looks like when graphed. So number 11, I've said over and over, you got to get y by itself, get y by itself. Well, number 11 doesn't even have a y. It just says 4x is less than or equal to -4. Well, okay, we're going to get the variable by itself. We want x alone, so we're going to divide by 4. And it's positive, so I don't have to do any of that flippy floppy stuff. It stays less than or equal to, and -4 divided by +4 is -1. If you remember the acronyms that we learned, X and no Y means it's going to be a Vux kind of a line. And so because the X is by itself and there's no Y, and that V means vertical. So I'm going to have a vertical line where X is -1. Well, X equals -1 right here. So I need a vertical line that passes through that, and because it says or equal to, I get to draw a solid line. So I'm going to draw a solid line right through where X equals -1. And then I have to talk about shading. Now I don't get to do the above or below part here because my line was vertical. There's no above or below the line. But less than -1, if you're thinking about this number line, if -1 is right here, numbers that are less than that are this direction. So you have to shade everything over here to the left. And that's what your inequality looks like when graphed.